Hello there. My name is Lincoln Atkinson, and I'm a developer on the Visual F# team at Microsoft. F# 4 and the latest version of the Visual F# tools come in the box with Visual Studio 2015. The entire stack, from the compiler through the IDE integration, it's now fully open source, and F# 4 marks the first F# major release that was planned and built entirely in the open. It was developed with significant contributions from both Microsoft and F# community devs. We're really excited to share it with you. In this video, we'll take a quick look at a few of the new features in Visual F# 4.0. We don't have time to cover everything, so we'll focus on just some highlights, just 6 quick picks. I'll walk through some demos of those features, then send you off with a few links to additional resources. The first 3 features we'll look at fall under the basic heading of "it just works." These are things you might even have tried to do in earlier versions of F#, but found that they weren't supported or maybe required workarounds. Constructors now work as first-class function values. Mutable values are now streamlined and simplified. And the functional style core collections API is now fully normalized across arrays, lists, and sequences. The next 2 features show off some of the advanced capabilities that make F# such a uniquely awesome data-centric language. Method arguments can now be exposed with reflected definition, which allows for some new metaprogramming scenarios. And type provider methods can now use static parameters all of their own, which really expands the power of type providers and even the simplicity of how they're used. Finally, we've added the ability to use the full VS debugger when developing and executing F# scripts, so we'll take a look at that as well. Okay, the first thing we're going to look at is constructors as first-class functions. In earlier versions of F#, if you wanted to invoke a type constructor, you needed to use short little lambdas like this. You had to use this direct invocation syntax. That works fine, but you'd think that it could be a little bit simpler, because after all, a constructor is it's really just like a function that returns back an instance of that type. So this works fine, and we now have a little hash set with some URIs in there. In F# 4, this is simplified. You can use the constructor like a real first-class function value. So instead of creating a lambda that just takes one argument, passes it directly to the constructor, just use the constructor directly as a function. Similarly here, we can just do that. Much simpler. It even works when there are multiple overloads to the constructor. For example, system.string has quite a few overloads for its constructor. Right now, we're going to use the one that takes a character array along with a start and length index parameters. So this works even with the new syntax. So if I just replace this whole thing with string as a first-class function, the compiler understands and it picks the right overload, and everything works fine. Now let's take a look at how F# 4 makes dealing with mutable data a little bit easier. So here we are in VS 2013 with F# 3.1. And we have a little for loop here which updates a mutable value. We have a function that basically just counts how many elements in a list satisfy some condition. So this works just fine, and we can use the syntax let mutable. But sometimes let mutable doesn't work. If the mutable value is captured by some sort of lambda or other closure, then the compiler will actually forbid you from using the syntax. So if we just refactor like this, use list.iter, this should be equivalent, but due to the details of the compilation, you're not allowed to use a mutable value. You have to use a ref value. And this is kind of confusing sometimes. The syntax is a little bit different, and it's just a little bit awkward all around. So this is what it would look like in F# 3.1 if you wanted to factor your function like this. So let's switch over to VS 2015 with F# 4. In F# 4, you can now use the mutable keyword everywhere, and the compiler will just do the right thing behind the scenes. It will automatically convert the value to a ref if needed. So The original mutable syntax works with the for loop, and we can also factor it as list.iter. And that works fine too, with no changes needed. The mutable value is converted to a ref behind the scenes, and you can just get on with your day. And the last feature that we're going to look at that falls under the heading of It Just Works is the normalization of the F# core collections API. Here we are in VS 2013 using F# 3.1. Let's say we want to transform a list like this. But maybe I decide I only want the distinct values from my original input data. What we'd like is access to some sort of an API on the list module that gives us only the distinct values. There is a function on the sequence module called sequence.distinct, but unfortunately that doesn't exist for lists. So the collections API is kind of lopsided, there are gaps. So what you need to do is you convert from list to sequence. After you do that, you then have to convert back into a list so that the rest of your pipeline works. And it's a little bit awkward, a little bit out of the way, and it's not great for performance either because you're converting from list to sequence back to list. In F# 4, we've completely normalized the collections API. So every API that exists on sequence should now also exist on array and should also exist on list in an optimized form. So let's switch over to F# 4. Now we have access to a dedicated implementation of list.distinct. We've added almost 100 new APIs to fill out array, list, and sequence. And it'll be much faster, it'll be much easier to discover, and basically it should just work. Okay, let's look at some of the stuff that's a little bit more fun, that really makes F# unique. In F# 4, we've added the ability to add the reflected definition attribute to method arguments. And what this lets you do is obtain not just the value of an argument, but also the syntax tree of the expression that was used to create that value. So let me give you an example. Let's do a little bit of charting. I'm going to load up the F# charting library and the F#.data type provider. So we'll pull down a CSV file of stock quotes. And from those, we can get the date and the adjusted closing value. So in a traditional charting API, you pass in the data, and it will draw it out like this. Looks pretty nice. But let's look at a way we could implement the charting API in a little bit smarter way. Let's look at this smart chart type. So here, I'm using the reflected definition attribute on the x and the y parameters. So what this lets me do is get access not just to the value of x and y that the caller passed, but also the expression tree which represents that value. So I can automatically label the axes or just put a title on my chart based on the name of the variable that was actually passed to this function. And to the caller, it looks like just a regular function call or method call, but we get access to all this additional data, and we can pull out, for example, names of values, expression trees about other operations, and we can really do whatever we need to. So if we go back here and we use this smart chart API, I've passed it a value called date and a value called price. So this can actually automatically label the graph with date and price. This is the kind of feature that you might have seen before in a language like R, for example. So new F# 4 features let you do things along these lines. And just to show you that I didn't hard code everything, let's use different variables here, n and n squared. Let's plot that. And sure enough, we get the nice automatic labeling. So there are a lot of really cool meta-programming scenarios that get unlocked by this feature. Okay, now let's look at type providers. What's new in F# 4 for type providers? Well, we've added the ability to specify a static compile time parameter, not just for types, but now for methods. So let's look at an example of how you might use this. I've created a regular expression type provider that gives us typed access to the capture groups, the named capture groups of a regular expression. So here I have a simple email regex, and it's got 3 capture groups: username, domain, and top-level domain. And we have strongly typed access to this. It works in the tooling. You get IntelliSense. It's this really cool experience that really makes data-driven programming great in F#. Similarly, maybe we have a phone number regex. You can get the area code out of that or the phone number itself. So this works really well, and people love this feature. But sometimes it takes a little bit of ceremony to get to where you're going. For example, you have to declare a type, then you get an instance of that type, and then finally you get the good stuff. What if this could be easier? So in F#4, you can specify this static parameter not just at the type declaration level, you can actually specify it now at the method level as well. So we can turn this whole thing into a single method call. Like this, and it does away with these first 2 steps, and the magic happens in step 1. So if we run this here, we get the domain out of the email address. Similarly, we can refactor this one. Get rid of these first 2 steps, and we now have a single provided method which takes a static parameter, and you can get all the data that way. So this makes type providers much more powerful, much easier to use, and just a lot more flexible in general. All right, finally, let's take a look at what's new in the IDE for F#4. One of the things that F# developers really love is the ability to use F# scripts along with F# Interactive. You don't have to create a full console application project in order to run a little bit of code, to test a little bit of things. All you need is some code in the editor, and you can execute it directly, line by line, in the interactive window. That's how I've been doing all of these demos. One of the downsides is that in the past, you could never use the Visual Studio debugger with F# scripts. So when you did have to do some serious debugging, it was a little bit tough. With VS 2015, we've added the ability to hook up the VS debugger directly to your F# scripts. Just right-click, debug in interactive, and everything gets wired up. You can set breakpoints and step through just as you normally would with a console application or any other Visual Studio project. So you can see our code running live right here. We've got the locals window, everything works. Set a breakpoint up here, step through with F10, set a breakpoint here, see when the first time we hit this case is. Sure enough, right after 14, current value is 15. So your scripting development experience is now a lot easier because you can actually do the serious debugging you need to when that comes up. There you go. That's a taste of what's new in F#4. There's plenty more new stuff in there I didn't cover, and plenty more great things to learn about F#, so you'll have to go check out some of these resources too. Fsharp.org is the home of the F# Software Foundation, and it's a great one-stop shop for general information on the F# language, how-tos, and getting started guides for using F# on Mac, Linux, iOS, Android, and Windows. If you're interested in helping us build the future of Visual F#, or maybe if you just have a bug to report, head on over to our GitHub page. For more information and announcements about F# 4.0 and all things F#, take a look at our team blog. And if you just want to dive in and start coding, download the free Visual Studio 2015 Community Edition, which comes with F#4. Thanks for watching.